In this video, we are going to look into using Microsoft Excel in solving linear programming problems. So first, I have opened Microsoft Excel workbook, and we need to ensure that add-in is installed in the system uh, to solve linear programming problems. So for this, we go to the File menu, and all the way down we have options. So when we click on it, we are going to get this window, and we click on this add-ins. So once we go to add-ins, we go at the bottom here in manage Excel add-ins and click on go. Here you are going to see an add-in called solver, and we select it and click OK. And then it is still working. So then when you go under this data tab, you are going to see this add-in called solver. So it may or may not be there when you open your Excel window. Similar method works in Mac as well. So right now I am using Office 365 in Windows. Now in my Excel file, I've already written few headings called variables, objective function, constraints, inequalities, and RHS. So first, let me insert an image temporarily where I have an LPP, which we will try to solve. So this is the problem which we will try to solve using this Excel. So as you see, this problem has 4 variables, x1, x2, x3, x4. So I write them as x1, x2, x3, and x4. We have to write down the initial solution here, and as we have seen in simplex method, one possibility of choosing an initial solution is to choose all these 4 as non-basic variables. So all of these are 0. Objective function is of maximization type, so I'm writing max here, and my objective function is this 30x1, 40x2, 25x3, and 35x4. So I write down this formula: 30 multiplied by x1. X1 is in this cell B2, so I select this, plus 40 multiplied by x2, so that is cell B3, plus 25 multiplied by x3, that is in this cell B4, plus 35 multiplied by x4, which is in this cell B5. Then I press enter. Now I'll display the constraints here. So I'm just naming them: constraint number 1, 2, 3, 4. Now first constraint is 2x1. So 2 multiplied by x1 belongs to this cell. Sorry, we have to start with equals to. X1 belongs to this cell B2, plus x2, plus 3 multiplied by x3 belongs to this cell B4, plus 2 multiplied by x4, which is in this cell. Then I press enter. Inequality is of less than equals to type. This is only for display purposes, and then right hand side 120. Now I enter the second constraint, x1 plus 2 into x2 plus 2 into x3 plus 3 into x4. This is also of less than equals to type. Right hand side is 90. Third constraint equals to 3 multiplied by x1, 2 multiplied by x2 plus x3 plus 2 multiplied by x4. We have this as well, less than equals to, and 100. The last constraint, x1, so equals to x1 plus x2 plus x3 plus x4 greater than equals to 10. Now, we still have this non-negativity constraint. If all the variables are non-negative, there is no need to specify this constraint here, as we'll see a little bit later. If some of the variables are non-negative and others are unrestricted, so you can mention that as constraint as well. For example, x1 greater than equals to 0 will become one constraint, x2 greater than equals to 0 will become another constraint, and so on. Once we have entered all this, we go to solver. So that will be under data. Now we reset everything. So whatever is there from before will be gone. Now we need to set objective function. Our objective function is here. So I simply click this cell. So it gives this address $b $9. I can just yeah. This is of maximization type. Now I have to uh, put variable cells here. So my variables are x1, x2, x3, x4. So I select this entire range. So I have selected these four variables starting from B2 up to B5. So you are going to get these variables here. Now I need to add constraint in this box subject to the constraint. So I have to add this first constraint to begin with. So when I click on add, I get this box, and then my first constraint is here in B40. So I click on this cell, choose the inequality type, it is less than equals to, and the right hand vector is 120. So I simply click on this cell. Uh, then I add another constraint. So my second constraint is in this cell. So I click on this cell. It is of less than equals to type, and right hand vector is in this cell. I click on add, so that has been added. Third constraint, still less than equals to type, and right hand vector is 100. And finally, the last constraint, so this is B17. It is of greater than equals to type, and then this right vector here. I click add and then OK. So as you see, all four constraints have been added here. Now there are choice of algorithms available: GRG, nonlinear, simplex, LP, evolutionary. We are going to solve it using simplex method. And as you see, you have a box here: make unconstrained variables non-negative. So if all variables are non-negative, so I can just click on it. So my all xi's x1, x2, x3, x4 are greater than equals to 0, and then I simply click on solve. So when I click on solve, you'll see certain changes in your Excel file. Your variable x1 is 5, x2 is 42.5, x3 is 0, x4 is 0. So this is your optimal solution, and the objective function value is 1850. So this is how you can solve linear programming problem using Excel. So this image was just for display purposes, so I have removed it. And similarly, as you have seen, these inequalities are only for display purposes. I had to choose these inequalities in the solver itself.